Okay, let's get started. So hello and welcome to the third iOS workshop from GDSC SFU. I am Jenkins, for those who are new here. I wanted to tell you that the Swift Student Challenge for 2024 is now open. You can go to this webpage to look at it. I highly encourage you to participate in it. And there will be 350 winners all around the world. I hope after this series of workshops you can build something and submit and try to be one of the award recipients. So let's do a quick recap of what we covered last week. Some of the important stuff from last week. The first thing is Closure. Closure is a great song from Taylor Swift and it's also a feature in Swift. The tool Swift doesn't have seem to have different opinions about closures. All right, so let's take a look at this function has any matches. So inside this parameter list, it takes two different arguments. The first one is just an array of ints. And the second one would be a closure that takes an integer and returns a boolean. What we can do is that we can pass in the less than 10 function inside there so they can be used inside the has any matches function body. So it sort of look like this. We're taking the entire function and pass that into the has any matches function. And because, and you can notice that these two types matches, it's both taking an integer and returning a boolean. So whenever we call a condition, the item is going to be passed into this function and it will return a boolean accordingly. And another thing we mentioned last week is that we don't even need to declare the function specifically. We can just return, we can just pass in a closure like this. And of course, we need the parameter list down there. And you can use an in keyword to separate the parameter list and the function body. And we also don't need that anymore. So since it is the last argument of this function, we can omit the name as well and write it like this. So that's just a shorthand. And because we only have the return statement inside there, we don't even need the return keyword, so that can be even shorter. And because you can see that the has any matches function is taking a closure that receives an integer there. So the compiler will be able to infer that the parameter would be an integer, so you don't even need to specify the type there. So that's even shorter. But if you're the laziest one, you don't even need the parameter name and just use a $sign plus the index of the parameter to replace that. So that's the shortest way of writing this. So that's closure, and the next thing we talked about is ARC, A-R-C, or automatic reference counting. So basically what that is, let's take a look at an example. So here's a person class and an apartment class. Inside a person, we have a reference for an apartment, and inside the apartment, we also have a reference for the tenant. And the tenant is just an instance of person. And then we create three different variables. All of them are optional. Then let's say we're executing this line up there. We're assigning the person instance to reference 1. So that for this instance, we have one reference to that. So the reference count for that instance is now 1. And then if we execute this line, reference 2 equals reference 1, then there will be two different variables referring to this instance, so the reference count will be 2. And the same thing happens for this line, the reference count will be 3. And if you set the reference 1 to be null, then this reference would be destroyed, and the reference count would go down. Same thing for this line, and also for this line. And when the reference count gets down to 0, then this instance will be destroyed. So that's how memory management happens in Swift for reference types. Then let's take a look at another example. So here we have two different variables. One is called John, another one is called unit 4A, and that one is an apartment. And we are assigning this person instance to the variable John. Now we have one reference to that instance. And then we create an apartment instance and assign that to the variable unit4a. So that also has reference count of 1. And then we assign this unit4a to the apartment property of John. So there will be another reference to the apartment. The reference count will go up to 2. And then similarly, we're assigning John to the tenant of unit4a. So that reference count will go up as well. But now there's a problem. Let's say we're setting John to null, so there will be no longer, this reference will be gone, and the reference count will go down. And we're setting unit4a to null as well. This reference will go, and the reference count will be 1. So none of these instances are referred by any of the variables, but we're not able to destroy these two instances because they are referring to each other, and their reference count is not going down to 0. So we have a reference cycle here. So how are we going to resolve that? So from last week, we added the weak keyword before the tenant variable. So as you can see inside the apartment, before the tenant variable, we added the weak keyword. So right now, this reference to that person would not be a strong reference. And that means that we are not going to increase the reference count when we assign a person to that tenant. So let's take a look at how that works. So let's go through that again. We create a person instance and assign that to John. Reference count is 1. Unit4a, another instance of apartment. And we assign the apartment to John. That reference count increase. And unit4a.tenant is John. As you can see, I'm using dotted line here, and that means it's just a weak reference that will not increase the reference count of the person object. And now we set John to null. And this reference got destroyed, so that reference count will go to 0, and this object will get destroyed. And because this object is now destroyed, the reference of that pointing to the apartment will also be gone, so this reference count of the apartment will go down to 1. And let's say unit4a equals to null, this reference will be gone as well. So this object will also be destroyed. So now we don't have the problem of reference cycles. So what's the advantage of ARC instead of using something like the garbage collection? Is that the first thing is we don't have the high usage, sudden high usage like in garbage collection. Because for, yes?
So if I remove the apartment reference, would it all, since it's a weak variable, would it automatically destroy the John reference also?
What do you mean by that? Yeah, sure.
Slide?
Yeah.
So let's suppose in here, if I destroy the apartment reference 4a, so what would happen then?
So in here, so if nothing, okay, let's go back to, this one. Yeah, so if you destroy the apartment instance here, because John, the variable John is still referring to the person instance, then it will still have the reference count of 1, because that is a strong reference to that instance, so it will not be destroyed. Yeah, because in here, the apartment instance is weakly referring to the tenant. That doesn't affect the reference count at all. So even if you destroy the apartment object, it will not affect the reference count of the person instance. Okay. Any other questions? Okay, cool. Okay, let's wait for the animation to finish. Right.
Sorry, Jenkins.
Yeah.
When you say sudden high usage, are you saying more sudden high usage of the processor?
Yeah. So inside garbage collection, so periodically your say like in Java, JVM will check for which objects are not used, and then it will clean up all those objects, and that periodic checking will suddenly has a high usage for your CPU, because it will need to check for each of these objects if anyone is using that.
And does it also make the code bloated too? Because you have to include the garbage collection for Java, right?
Mm-hmm.
I'm like, you can actually, when you write code using Java,
Yes.
The code comes on the garbage collector there. So it is quite big, right? It's bloated, is it correct?
Uh, not sure about the details because I'm not really of a Java developer.
Okay,
Yeah,
okay.
but I think that would be the case.
So why is it like you say you usually don't have to worry about this when using a database, so
Oh,
why
that's
is that so?
yeah. So that's the second point. So for this point, as you can see, when we are building like something like this, we have person referring to apartment and apartment referring to the person, and we have to deal with all the reference cycle and things like that. But if you are using a database library in Swift, like core data and also Swift data, you probably won't need to worry about this, and that is because this layer of logic is wrapped inside the library itself. So in actual use cases, we rarely need to worry about this when you're modeling the data. Yeah.
Thank you.
Yeah, that's just something I want to make clear. And also, you don't have to set the variables to nil every single time, and that is because like when you're exiting a function, all these variables will be destroyed, so those references will be cleaned up as well. Yeah. Okay, so the third point is that this mechanism only applies to reference types, and we will see some types that are not reference types, for example, like enums and struct later. And yeah, variables will be dereferenced when we are out of scope. So when we are exiting the function, like I mentioned, all of these variables will get destroyed automatically instead of having us to set them to nil manually. Okay, so let's take a look at some new stuff. So this is an enum. So enum in Swift have been greatly enhanced. First, enum have a value called a raw value, and each of these enum cases correspond to a raw value. And at the bottom, you can see that we can obtain the corresponding value by accessing the dot value. Specifying the raw value type is also simple. Just declare it on the top of the enum. As you can see, this one is an integer. And this is very useful for solving, for example, stringly type issues. Imagine that you have an enum specifically for storing different types of error messages, where each case's raw value can store the detailed content of the message. Or as shown in this example, our first case A's has a raw value of 1, and Swift will automatically assign raw value for the other cases based on this. For example, 2 will have the raw value of integer 2, 3 will have a raw value of integer 3. And this makes it easy to compare card sizes later by comparing their raw values. And another useful feature is that enums in Swift are also a kind of value type. So the classes we have seen before are reference type, and structures, which you will also see later, are value types. Value types do not need to worry about reference count, as I mentioned. So in Swift development, protocols, which are interfaced in other languages, combined with value types like enum and structure, are a lighter and more convenient choice, unless your logic really requires using references. So returning to this example, because enum is also a value type, you can also add functions to it. In the simple description, we're returning different description of the cards by switching the instance itself. Okay. Do you got any questions on enums? Nope. Okay. And when you have a raw value, Swift will automatically add a new initializer for you. And this initializer is optional, meaning that if the raw value you pass is not valid, then it will return null. Okay. And that's not all. What if you want to bind more than one value to a case, right? For example, we have an endpoint where each get might result in different scenarios. The first one is successful data retrieval. Each piece of data containing 2 strings representing the sunrise time and the sunset time. And the second scenario is that the data cannot be retrieved, perhaps because the server is down, and we get a fail response with an error message. And essentially, these are 2 cases of an enum, right, if you think about it. a successful result with 2 different strings, and a failure case with an error message. And in Swift, as shown in this example, you can associate new value with each cases called the associated values. And Swift will create corresponding initializers. And like as you can see here, for the success and failure cases, we're creating 2 different case instances right here. And then you can use the special switch let syntax to pattern match the corresponding values, as you can see down there. For example, in the switch, if the success corresponds to the result of the server response case, then we're going to create 2 constants, placing the first associated value 6 a.m. in the sunrise constant and 6:09 p.m. in the sunset constant. And this allows us to access these values inside a case block. And here you can see there's only 1 dot before the result without enum type, because if the type you're referring to can be inferred in Swift, you don't even need to write the enum type. So that's why we're only having a dot right there. And here, since the success is a server response, each switch case below must be a server response. So we can just omit the type there. Okay. Yeah. So this is the most confusing syntax in Swift. Actually, this last is for these 2 constants. So actually, in this case, we're creating 2 different constants. One is called sunrise, and the other one is called sunset. And this one is trying to say, like, for this constant success, it's checking whether it's a result case or a failure case up there. And if that's a result case, it will try to create these 2 constants and assign the corresponding values to these 2 constants. So in this case, it's trying to grab the 6 a.m. string to sunrise constant, and that 8:09 p.m. to that sunset constant, and try to assign those. That's why we have a left keyword here. It's not the most ideal way of doing things, but yeah, it's how we do it in Swift.
So if we switch success to failure in the switch case, would our answer be failure out of cheese?
I'm sorry?
If we switch the keyword success with failure in your switch statement, would our final print statement be failure out of cheese?
Yes. Yeah, so you mean replacing this with this one? Yeah, that would be the case. You got it. All right, any other questions? Cool. All right, so we also mentioned structures, which are quite similar to enums we just saw. It's also a value type, and so we've also provided default initializers for them, unlike classes, which will require you to create your own initializer. And value types has another feature. A structures method cannot change the structure's own value by default, and class methods can change class properties, but if a struct method wants to make changes, then the developers must mark the method with the mutating keyword. This is because besides better optimizing performance, this also prevents bugs that can occur because of intentionally modifying values inside a function that should not. Okay. And since value types cannot do inheritance, we also have protocols, which are equivalent to interfaces in other languages like Java. And each class structures, etc., can conform to multiple protocols. We are not limited to one, but inheritance is limited to one. And if you want a property to be at least gettable, you can specify it as shown in this example by writing the get keyword after that variable. And remember, we previously created properties with custom getters and setters. And if we don't want to write a setter, then it will be a get-only variable. Okay. So notice the use of the mutating keyword in the declaration of simple structure to mark the method that modifies the structure here. The declaration of simple classes doesn't need any of that because methods on the class can always modify the class. Okay. And we can also add protocol conformance to existing types through extensions. For example, here we have the required properties and methods to Swift own integer type in an extension, making it an example protocol. Extensions don't just have to add protocol conformance, you can also use them to extend the functionality of the types in other libraries that you don't have direct access to modify. For example, if we need the date type to output a particular date format, then we can add an extension to date to add a new method to format the way you want. Okay. And similar to superclasses, you can use protocols to specify the required types. But if you do, you cannot access methods and properties of the type itself beyond the protocols. And if you do so, Swift will throw an error. And next, I will show you the generics in Swift. So very similar to C++, you specify an unknown type with 2 angle brackets and use it in your function or other body. For example, like the class body if you're declaring a generic class. And when you use it, thanks to the type inference, you don't need to specify the item, in this case, is on the calls, what the item is on the call side, because Swift can infer the types based on your arguments. Okay. Because usually in other language, you might need to also write angle bracket string right there, but because Swift can infer the type, so you don't have to do that. And if you really think about it, optional values are just a generic enum with 2 cases. One corresponds to no value, and the other one is representing some value. And in this case, some value would be just an associated value of the generic type. So yeah. Okay, so we're getting down to some very Swift specific features now, which you don't often see in other languages. So this one's called a proxy wrapper. So let's look at what a regular wrapper in other language might look like.
Jenkins,
Yep.
how did the Swift, the people who made Swift justify making this Swift specific features?
Mhm.
Like what type of problems are they trying to address with these Swift specific features, and why they cannot be done any other ways?
Yeah, I will show you some examples. Maybe after you look at the examples,
Great,
you
thank
will
you.
have an idea of that. Yeah.
Thank you.
Okay. Yeah. So this is a simple wrapper that we are creating with a struct. So what this one does is whenever we assign a new value to it, it will try to capitalize whatever string you provide. So for example, we're first creating that with the string Alex, and then the A will be capitalized, and when we set that to Bob, the B would be capitalized. So that's a very simple wrapper that you can also do in other languages. But this way we have several problems. The first problem is that this is no longer a string, right? You cannot pass this to other functions that require a string. And you cannot use the methods that requires the types to be a string. For example, you cannot add this one to another string, then that's a problem. And this is not very convenient, right? You need to write a lot of code just to do that, and it's not very easily applicable. Because like for every single time you're gonna write a wrapper like this. So in Swift, the solution looks like this. So you're also creating a struct, and this time we're calling that capitalize, and you can mark that as a property wrapper. And when you're doing that, you will have to provide a property called wrapped value, and also an initializer that takes a wrapped value. And after you have that, you can write something like this. You can just mark your property with capitalize. And then whenever you are using this property, you can just see that as a string. But when you're setting it, it will call whatever you provide inside your property wrapper struct. So say like you're assigning a value to the first name property of the user, then it will go to, they will trigger the disset listener of that property right there and capitalize the value. Right? It's just one line solution right now, or even a half line. Okay. So the call side would look like something like this. You're creating a user, and when you assign these values inside the initializer of that, it will automatically go to the capitalized property wrapper and try to capitalize that. And you can try to print out the values and check if that actually works. And the same case goes for when you're assigning these values using accessors. So yeah, that is property wrappers. Do you got any questions on that? Okay, if not, let's go to the next feature called a result builder. So let's say we have a function like this. What this function does is pretty simple. It's just return one string. But you cannot write a function like this. So you list 3 strings and you maybe you want to combine them into one string, and you cannot do that. And because we're not able to infer which one we want to return, and we also don't know how do we combine these strings. So when you write something like this, we will have an error. But what you can do instead is like maybe we can create a structure, and then we can create a static function called build block. And then this build block would take a variadic variable. What a variadic variable is basically just an array with infinite amount of things you can provide. Right now you can just treat that as an array. So after you have all the parts you need inside that function, then you can just join them together by adding a separator between them. So you can just do something like this called a break block function and then pass all of them in. And the nice thing inside Swift is that you can mark this very special structure with result builder. Okay, and then this a simple string result builder will become a result builder itself, so that you can use that to annotate other functions to be a simple string builder as well. So in this example, we're marking the function makes sentence 2 as a simple string builder. Then all of the things that could be returned inside this function will be sent to the build block body of the simple string builder. So basically treating all of the possible return values as an argument to that function, and it will go into that function and try to join all of them together and return something new for you. Okay, so now that this is something valid. And if you still remember what we talked in the first workshop, we have something like a stack view. And what if this initializer of the stack view is a result builder, right? So you can do something like this. Okay, inside the initializer of the stack, horizontal stack, we can just pass in all the views that we want the stack view to render. So this one would correspond to the hello world stacking horizontally. And this is also a view, so that we can wrap that inside something else as well, right? And we can just pass add that inside a VStack. I think I'm making an error here. This image should be outside of that instead of in there. All right. Yeah. So this is how we would create this view very simply. Just like compared to what we had before, I need to correct this as well. What we had to do before is like we create the vertical stack view first, and then we specify the axis of that. We need to change the alignment, do the same for the horizontal stack view, and then we create a hello label, the raw label, and the image view. And then we need to add all of them to the arrange subview array of those stack views. We have to do all of that, but with result builder, we can just simply write these few lines and we have everything ready. Okay, so the next question is, how do we modify the views, right? Because right now we cannot do something like this. If we first create the hello label and then we change the text color of it, we would not have a return statement there, right? It's no longer return any values. So this would not be valid inside result builders. So what we can do instead is recreate something called a modifier. So it will look something like this. It's just a method for the text structure. What it does is it will try to modify the view based on whatever you provide in the argument list, and it will return a new view, so that you will have a return value in this case. That's how you would modify that. Okay. Yeah. It's doing weird. It's 6:47. Should we take a break?
We could get it. You can just continue then.
Okay. Yes, the next part is demoing and we try to build something, so I guess, yeah. Right now we can take a break, maybe. I'll try to fix this connection.
Quick question.
Yep.
Does Swift